Today, we are going to talk about life beyond Java 8. And so this talk is basically going to be the TLDR, the too long didn't read version of everything that's sort of happened in the Java community since the version of Java 8, because things have been moving quite quickly and there's quite a lot that developers probably need to know. But I'm going to save you the time of having to do all the research and read everything and wade through everything and try and give you the sort of high level overview of what's happened in the Java world since Java 8 came out, which is, it's a while back now. How many years? Like 5 years or something since 8 came out. Yeah, it's getting on a little bit. So why am I talking about beyond Java 8, especially since the current version of Java is Java 14, which sounds significantly higher than 8. This is the results of the 2020 the 2020 Developer Ecosystem survey that JetBrains did this year. And in this year's survey, we found that 75% of developers are still using Java 8, 32% Java 11. Now, these percentages don't actually add up to 100 because, as I'm sure most of you know, plenty of organizations use more than one version of Java. But regardless, you can still see a very large chunk of developers and their applications are running on Java 8, even though Java 14 is our most recent version of Java. We do have a good chunk of people who are now migrated onto Java 11, it is higher than last year. It's 10% higher than last year's developer ecosystem. So people are migrating to Java 11, which I'm quite happy to see. Other surveys show the same sorts of numbers. This is the new Relic Survey, which shows, again, the majority of people, over 85% running on Java 8. This is a slightly older survey, but again, you see the same sort of distribution of a large number of applications and developers still using Java 8, a smaller chunk of people using Java 11, and then the rest of the versions are kind of smattering of different versions of Java. This was my super scientific Twitter poll of my followers. So, I was using a survey tool which limited me to 100 responses. So it's not really statistically significant, but still, using Twitter, I managed to gather the same sort of distribution: a huge chunk of people on 8, a chunk of people on 11, and then a smattering of people on different versions, including a few unfortunates still on Java 6. Those of you on Java 6, I don't have much to say for you. You've got to get onto 8 first before you can take any of this into account. So those results might be a little bit surprising to people who are not really aware of the sort of, let's say, politics around the new release cadence. So I want to talk a little bit about the new release cadence, the new licensing and support, particularly by Oracle, and how each version of Java is updated going forward, because that has a very big impact on those results. So as you probably know, since Java 9, which was back in 2017, we've had a new version of Java every 6 months. Like clockwork, in March and in September, we get a new version of Java. And the original goal from the Java developers' point of view was maybe some of these would be quite small and have very few features, particularly for the end user developers like us in terms of syntax, and maybe some might get some big-ish feature which is interesting to us. But the point was to make sure that they released something every 6 months so that Java is constantly evolving, and so that we can pick a version of Java that actually works for what we want. What it actually means is, because, not surprisingly, vendors like Oracle don't want to be supporting all of these different versions of Java because it's going to get quite unwieldy very quickly, we've ended up having 2 different types of release. There's a long-term support release, there's the sort of everyday release, if you like, the 6 monthly releases, and specifically allocated long-term support releases. So Java 8 was a long-term support release. It falls under the old model where we used to release, Java was released every 3 years or so, and so that version of Java would be supported for at least 3 years. So Java 8 falls under that long-term support release category. Java 11 was allocated as a long-term support release, and Java 17 will probably be a long-term support release too, because that's 3 years on from Java 11. So every 3 years we will have a release which is the designated long-term support release. And this is so that large organizations, enterprises, people who want stability, they know which release to go for to make sure that they can use that release sort of safely, securely for 3 years and not have to worry about keeping up with a 6 monthly release cadence. Now, it's important to understand that these long-term support releases, the actual support is paid for support from Oracle. This is the Oracle story for the Oracle JDK. And that's where things have become a little bit different since Java 11. Traditionally, we usually used the Oracle or before then the Sun JDK. Now we have to be a little bit more aware of which vendor's JDK we're using. If we're using Oracle's long-term support version in production, we're going to have to pay for it. So we do need to understand that. Basically, it means that now you have two different choices going forward for your applications. I don't want to cover this in too much detail because this is kind of a political backdrop, which is really much more important for the sort of decision makers inside your company. But it is important to understand the difference between the long-term support release and the 6 monthly releases, and why we have a bunch of people on 11, on 8, and not so many people on the versions in between. We have two choices going forward. We stick with a long-term support release, which in this case would the current long-term support release is Java 11, or we upgrade every 6 months with the 6 monthly release cadence, in which case at the moment that would be Java 14. So in theory, no one should be using Java 9, Java 10, Java 12, Java 13. You're on 11 for long-term support, or you're on 14 as part of the 6 monthly release cadence. Yes, so this is what I just said. You can use the Oracle Open JDK for free, but this is the one that gets released every 6 months. And that's the current version is Java 14, or you use the long-term support release, but you may have to pay for it in production. In the Oracle one, you have to pay for it to use it in production. This is Java 11. You don't have to use the Oracle one. However, there are plenty of vendors. It's all based off OpenJDK. All the same functionality is expected. It is Java. It's all branded Java, and it all follows the Java APIs and guidelines. So it doesn't matter who you get your JDK from. It will have all the functionality and features that you expect. The vendor choice is really all around how their support works, how much you pay for it, what you want from the vendor, basically. So there are lots of different choices. I would particularly be interested in looking at Adopt OpenJDK because it's free and support-led, community-led support. So I think Adopt OpenJDK is the default, I think, if you're looking for a free OpenJDK to use. OpenJDK was very recently joined the Eclipse Foundation, and it will soon be called Eclipse Adoptium, apparently. Eclipse, obviously, they also have an IDE called Eclipse, but the Eclipse Foundation is not the IDE. So I'm allowed to say things about Eclipse Foundation. It's not the IDE. So yes, Adopt OpenJDK will soon be Eclipse Adoptium, and this is the free community-led build of OpenJDK. All of that said, all of that sort of political background out of the way, why should we bother upgrading to either Java 11 or Java 14, particularly since this seems kind of complicated and I'm not really sure why I want to do this. So let's take a look quickly to begin with at the Java features available in each of these versions. I'm not going to step through version by version, as in I'm not going to do Java 9, Java 10, because there's no point doing that. What I will do is I will step through in terms of, for Java 11, the long-term support release, these are the features you'll get. And for Java 14, the current release, these are the additional features that you will get. So you can get an idea as a developer why I might want to use one of these versions of Java. So first, starting with Java 11, the current long-term support release. What are the features that are available to me in Java 11? One of the most interesting features, I think, is JShell. One of the things, this is the REPL for Java. One of the things that's very interesting about JShell is that it doesn't actually matter which version of Java I'm using in production in my application, because JShell is a separate tool which I use separately from my own application. So let's start our demo here and let's take a look at JShell. So from the command line, I'm going to use the Java 11 version because we were talking about Java 11. So I can just run it from the bin directory of my Java home, and I should be able to get JShell. This gives me a time to have a bit of a rest while it starts JShell. You can see I'm using it from version 11. And so what does JShell give me? JShell gives me the ability to basically try out Java from the command line, which we didn't used to have that. So I can say things like system, and I get tab completion too, which obviously being used to being in IntelliJ IDEA, being used to an IDE, having things like tab completion is somewhat useful for me from a command line point of view. So I can do system.out.println, and I can say hello, and I close that off. And have you noticed something really interesting about this? I don't have to have a semicolon. Yay! It's a small thing, but these small things make a difference, particularly when you're talking about from the command line, from scripting point of view. It's nice to be able to run it without the semicolon. However, I still have to type system.out.println, but that's obviously another thing. What else can I do? So I can define variables, of course. I can have an int, my int. It can be whatever. Oops. And obviously, one of the nice things to use JShell for is trying out new features in Java. So I don't need to type int. I can say var, my int 2 equals something else. Now, using var instead of int doesn't really save you very much because it's still 3 characters. So in this case, maybe that's not the most exciting use of var, but we will see a bit more use of var later on in this presentation. I can also define sort of temporary anonymous variables by just doing that, and it will assign me to $4. So that's kind of cool. I can obviously create methods. So I can say, what can I say? I can say void print me something, and then I can say, let's call another method here. Let's call it print something here. So I've just created this method print me something, and it tells me I can't call it until I define the method print something here as well. So JShell also supports forward references, so I can start building up slightly more complex versions of the code. I don't just have to assign simple variables or whatever. So then when I just define, can I do that? Print something here? No, I don't have to have completion for that. Print something here. This needs to be a void, obviously. And then I can do system out println this. And then when I call print, what am I calling? Print me something. Now I can call print me something because I've defined the method print something here. Okay, so you get this idea that the JShell, the REPL, allows us to play with different language features. It allows us to build up gradually bits of code, potentially creating something a bit more complex. You can also use this. You can export these. You can export the code out into a file. You can import files. So you get the idea that maybe you can also use it for scripting and so forth. So it's quite an interesting tool. It's really good for prototyping. It's really good for playing with new languages features. It's good for learning stuff, whether you're a beginner or you're trying out new versions of Java. And also potentially you could use it for, I can imagine using this for one-off scripting type stuff, like migrating from one particular, like a script which is going to migrate from one file format to another, something like that. It also has a series of commands, so I can type vars, it'll show me all my vars. I can type methods, it'll show me all my methods, and I can also what else? Okay, so I can. This is what I was talking about. I can save, and then give it my file name. Let's call it JShell. And then if I wanted to, I can open the file as well. So it's a nice little tool to be able to play with stuff. And like I said, you can use this completely independent of your application. So this you could use Java 15 JShell if you really want to, because it's completely off the critical path of your application. I was going to stop for questions at some point. Do we have any questions already?
We don't have questions for now, and that's the reminder. Please, folks, ask your questions into the chat to make it easier. #question, and then we could stop every once and then to ask questions there. I actually have a question with you. Probably will get to it later. I don't know with the IntelliJ integration of JShell. So does it run the very same JShell that you would run in a terminal as well with the with the same auto-completion features, or do you get stuff on top of it, like some more auto-completion and some more IDE features that you would expect when writing code?
So that's a really great question, but I sort of wish you hadn't asked that because our integration is not as good as I would like it to be. But let me show it to you because I hadn't planned to show it to you. So if we look at my IntelliJ here, we do have, my screen sharing is not letting me get to, here it's in Tools. It's called JShell Console. And then I get a JShell console and I can pick, the screen sharing thing is completely in the way for me. So I can pick the JDK, I can pick the class path and so on and so forth. So I basically do the same thing. It is working. It doesn't always work. So I'm getting tab completion like I'd expect to get. I can do exactly the same thing I did before. And then I can press Control and Enter, I think, to run. No, Command and Enter. Yes, so I can use Command and Enter to run this file. It's very similar to the Groovy console. To answer the basic question, the IntelliJ JShell console is not, it's not JShell. This window here is not JShell. It's not the same as the terminal window I had open. What it is it's the IntelliJ JShell console hooked into the JShell API under the covers. So in some ways it can offer the best of both worlds, or it can offer like not really either of the two worlds. So as you saw, I got tab completion, and IntelliJ IDEA calls down to JShell to run the script, so I can run it without the semicolon, and it will do what I expect it to do, and so forth. So I get the functionality I get from JShell, but it's not, the actual editor is not using the JShell editor, it's using the IntelliJ IDEA editor. So we're hooking, JShell has an API. We hook into the JShell API and use that. We have the potential to potentially use things like live templates and stuff in here, which last time I tried didn't work. So let me see if I can get it to work. So if I do a live template for system out, yeah, no, I don't get live templates, but potentially we could improve the editor for the JShell console to allow all the IntelliJ support that you expect to get. There is code completion, and there are some of the features that you expect to see inside IntelliJ IDEA. I would like to see live templates in here because live templates is something I use a lot that's not currently there. One of the things I would really, really like from you, if you use JShell, if you use the console inside IntelliJ IDEA, is I would like for you to raise tickets in the UTrack system to tell us what you're trying to do so that we can improve the tool to work for you. Because what we found is that we don't have a lot of use cases we haven't had a lot of user experience reports of people saying, I'm trying to do this kind of thing in the JShell console inside IntelliJ. I need it to support this, that, and the other. So I really hope that people will raise tickets with us and say, this is the functionality I expect to see, because without that information, we can't really improve it to do what you need it to do. So let's carry on. Like I said, I'm going to go through the Java 11 features, then the Java 14 features. So I will try and remember to pause at the end of the Java 11 features for questions. So you can ask me any questions about the features that you've seen for Java 11. That was JShell. Next is var. I gave you a quick glimpse of var. I gave you a slightly pointless glimpse of var because I used var to replace int. So I just replaced 3 characters with 3 characters, which wasn't very helpful. Let's take a look at some of the examples. I have var here. This is a sample code base that I use to demonstrate a bunch of IntelliJ IDEA features. This is on GitHub if you want to take a look at it. The link will be available at the end of this presentation. There's a list of best practices for using var. var is not a magic bullet. You could replace every single declaration here with var. For any locally declared variable, you could replace it with var. The reason why we have a bunch of guidelines on best practice and style is that the idea behind var is to reduce boilerplate and aid readability. Now, there's a difference. I talk about boilerplate quite a lot. There's a difference between boilerplate, which is sort of needless repetition of code which gets in the way versus a certain level of verbosity which actually aids readability. For example, if we get rid of like all of our code, there's nothing to read. And if we call every variable I, and if we shorten everything, then it's not very readable. So applying var everywhere is the equivalent of calling all of our variables by something with a single character. So it's something to use with care. It's something to think about. Does adding var here aid readability? So I want to go through some of these example style guidelines to give you an idea of where var might be helpful and where it might not be. So here we've said choose variable names that provide useful information. So if you have a variable name called temp, for example, and then you call that var, actually IntelliJ is quite helpful. This is new, by the way, so I haven't changed the presentation to update this. IntelliJ usefully tells you that actually this is a list of people objects, but without that hint. Can I get rid of the hint? Not yet. Without that hint, all you get is I have a var temp, and that means very little to me. So it's only really useful if you have useful names. Like if this is called, let's refactor this. Let's call it people. Then I have a var. Let's get IntelliJ to change that. Replace explicit type with var. Then var people is a bit more readable than var blah, var temp, or var thing. So if you're going to use var, use a readable variable name so that it still adds to the information that you have. Minimize the scope of local variables. This is good practice anyway. So if your local variables are declared at the top of the method is like 300 lines long, and you use it further down, it's very difficult to see like what is that variable, how has it been changed over the time, like what am I doing with it? And if you do that in the case, if you add a var onto it as well, it becomes kind of a bit more complicated trying to see, again, it's a list, that's not very helpful. What is the list? What is it doing? How am I iterating over it? Where was it changed? So it's always a good idea to try and reduce the scope of your local variables anyway. A good place to use var is where you have repetition of type information. This is where it's really important to understand that var is not dynamic typing. It's about hiding declarations of types where the type information is repeated. So this output stream is a byte array output stream. In Java, prior to Java 11, technically prior to Java 10, you have to say byte array output stream is a new byte array output stream. Now that kind of seems somewhat redundant since I've just said that word twice. So here is a good place to replace that with var. I don't need to say byte array output stream twice. I can see at a glance that this is a byte array output stream. It's a good place for using the word var. On the other hand, because var is about replacing known type information, it can't do magic. So here I have a list, I create a list of strings called one. This is actually another feature inside Java 11, which we'll talk about in a minute. So I have a list of strings, so I can replace that very easily with a var. Now, this is declared as a list of strings, but I think IntelliJ won't let me turn that to a var. Yes, IntelliJ won't let me turn that into a var magically, because if I turn that into a var, suddenly this is a list of objects. And the reason is because up here, we use this string for the compiler to know that this is a list of strings. Here, we have no type information here. So as soon as I replace my list of strings to something with no type information, then I end up with a list of objects. So you do have to be a little bit wary when you're using var, not to completely erase all the type information so that you get something which is a little bit different from what you expected. It's the same here. So if I turn that into a var, it's still going to be a list of strings. And if I turn this into a var, actually, IntelliJ will do the right thing here. It actually then let's do that again so you can see what happened. Here, we have an array list of strings. Here, we declare, this is the diamond operator from Java 7. This is perfectly acceptable, valid Java code. But if you just replaced this with a var, you would end up again with a list of objects because you haven't put the type information here. IntelliJ, when you tell IntelliJ to turn this into a var, it actually moves the type information to the right-hand side so that you don't lose it. So So this is var, and it can be useful in a bunch of places. Fine, it's useful for reducing boilerplate. Okay, that's fine, big deal. It can be useful in things like stream operators. If you want to break stuff up and you want to say, I might want to say here, this is, so this type information is somewhat unwieldy. So if I extract this into a variable, let's see, this is the map entry set. I might want to extract that just to make it more readable, to sort of see what is this part of the stream operation. But I don't really need to know about this. So this is another good place where I can replace that with var. And again, like over here, we have a whole bunch of generics. var is particularly useful when you don't really want to redeclare the generic information everywhere. So I can just turn that into a var, get rid of all of that, and the same up here. So I just get rid of all of that. Great. So it's good for reducing unnecessary boilerplate text. It is not necessarily something where with IntelliJ you could say replace everything with var everywhere across the code base. I don't recommend that because the point about var is to aid readability. It is not a magic fix for everything. So I know I spent quite a lot of time talking about these three letters and it's just three letters, but I think it's quite interesting because var it's a smallish feature, but it requires a lot of developer thought, like, is this the right place to use it? The whole point is to aid readability, to reduce boilerplate and make the code cleaner and easier to read. Convenience factory methods for collections. This is one of my favorite features that came in. It came in Java 9, so it's available in Java 11. We just saw this in some of this example. So let's look for, yes, Java 9 inspections. So in Java 8, if you want to create a list, you'll do something like arrays.asList to create a list. That's kind of fine, but what we often forget is that this list is actually not an unmodifiable list. It's not an immutable list. You can't add to it, but you can change elements in the list. So sometimes we use this as an unmodifiable or immutable list, but it's not. So it's actually not safe to use as an immutable list. So if we really want to, we should be wrapping that inside an unmodifiable list, which is, it starts to get a little bit clumsy. All I really want is this set of elements, and I have to actually add more boilerplate around the outside to create that list of elements. Now in Java 11, you can just say list.of, and then you'll get an unmodifiable list of just the elements you want. Now that's useful for list because you don't have to remember to wrap it inside unmodifiable list. It's much more useful for set. So to create a set of two elements, originally you have to put it inside an array list, pass it inside a hash set, wrap it inside an unmodifiable set. And that is very clumsy, which is probably why Java developers traditionally are not that good at choosing set as a data structure where it's the right place to use, because it's quite complicated to create a set. Now with Java 11, you can just replace that with a set.of. So I can have a set of that. And this is really helpful. We'll find this helpful probably in production code, but definitely in test code, where we want to create just a simple set of objects where a set is a good way to make sure you don't have duplication and so forth. You can do the same thing with map. With maps, when I used to work for MongoDB, one of the things we used to do a lot of was creating map data structures. So you have key value pairs. This is really common for a document database. You want a key and a value. In Java, it's a little bit clumsy to create maps, particularly if you know what the values are. You're going to end up putting them inside some sort of big static block like this, or there's a few different ways of doing it, but they're all kind of a bit nasty. And again, if you want it to be immutable, you have to wrap it inside your unmodifiable map. So I can, in Java 11, I can replace this with a map.of entries. Now a map is obviously a little bit more complicated because you have key value pairs rather than just a set of values or a list of values. So you end up with this. So you have a map.of entries, and then you have, let's static import map.entry. Where's my static import? Add a static import for map.entry. And so then you can have of entries where you've got key, value, key, value, key, value, so on and so forth. That's kind of fine. It's still a little bit clumsy, but it's not terrible. It's a bit more fluent. It's a bit more readable. If you have fewer than, I'm just going to undo that. If you have fewer than 10 entries, then there's a simpler way of doing it. So we can, let's see if IntelliJ does the right thing. Map.of. So then you just alternate key value, key value, key value. And IntelliJ will tell you that. I might actually let's get rid of those parameter hints. Do not show hints for current method. So then I get key value. And again, it's a convenience method. That's all it really is. I found myself using this a lot, particularly for test data, particularly where I know, particularly UI stuff where I know the values which are going to be on the user interface. This is really helpful. Collecting to unmodifiable collections. Now, if you're using Java 8, obviously you know about Lambdas and streams. That was a great thing which came in Java 8. This is another reason why developers are reluctant to move off Java 8. They've got Lambdas and streams. They're kind of happy. It does what they want. They don't need any more functionality. In Java 11, you can collect to unmodifiable lists, unmodifiable sets, and so forth. So this is just another really nice addition. Again, make sure you've got some safety around immutable data structures and so forth. So instead of just doing collectors.toList, you can say collectors.to unmodifiable list. So you know the person who is consuming that list is not able to change it or do anything nasty to it. Again, it's safer, it's better for multi-threaded code and so forth. It's just a nice addition. We have new methods on the Stream API as well. This was something which I really needed. When I did my Java 8 demo when Java 8 came out, I was consuming a never-ending stream, if you like. So it wasn't actually from an array. It was actually from a socket. So I'm consuming the stream like forever. What I wanted was something which would consume that stream until some condition was met, and you couldn't do that with Java 8. Now with Java 11 you can. You use take while and give it some sort of criteria. So you say consume this stream until this condition is met. There's a sort of a sibling to this as well, which is drop while. So ignore all elements in the stream until some condition is met. It's again one of these quite nice additions, just makes things a little bit easier for us. Predicate.not. This is one small addition to the language, nothing groundbreaking. Again, it's all about aiding readability. Let me just quickly show you what this looks like. This was Java 11. Java 11. Use predicate not. So in Java 8, if you want to filter out everything that is not some value, so for example is not empty, you have to use your exclamation mark and say is not empty, and that's fine. That works. It's readable. We know what that means. I mean, humans are a little bit bad at parsing not versus a positive case, but it's kind of okay. But some people just feel a bit happier for whatever reason using method references, and you can't use method references with your exclamation mark. In Java 11 instead, let's comment that out. You can do the same thing and say, this is from java.util, you can say predicate.not and then pass in your method reference here. Let's static import that. It's exactly the same thing as this. In this particular case, it's actually longer to use the method reference, but it's a stylistic thing. It just gives you the option if you want to use method references. If you find this more readable, because negative cases are difficult to read for human beings, then it's quite nice the fact they added a predicate.not to let us write code which we think is more readable. New methods on optional. We had a bunch of new methods on optional. Let me just see if I can find the list of them. Hold on a second. I've got 500 things open on my various screens, so I can remember what all the examples are. New methods on optional. Let's go to optional. I liked optional in Java 8. I'd been working on a code base where we had a lot of values which may or may not be null, and it was really difficult to know what that null meant. Did it mean something had gone wrong and something hadn't been initialized? Did it mean it was allowed to be null because it hadn't been set? Was it null? Like, null has no meaning. Null just means it's not there. Optional is a really nice way of saying, look, you asked for something and I didn't find it, so it's just not there. Then that allows me to reason around it. So if I get a null back from a method, I don't know what that means. Does it mean you didn't find it, or does that mean something went wrong? Do I need to handle it in a particular way? And in some applications, as I'm sure you've discovered, that null can mean all three of those things, and you don't know which one it is. With optional, I can say if the optional is empty, then I make a choice. What do? Do I throw an exception, or do I get another value, or do I set some default value? So that was a nice thing about Java 8. However, it was a little bit, it was the most basic thing that would work. So you have your if present, and you could do optional. Let's have a look. Here's a standard one here. So you have an optional dot is present. You can do an if, and then you can do a get. That's like the clumsiest thing you could do. Or you could do if present with a Lambda expression, but there wasn't really very much more you could do. With Java 11, there are far more ways of expressing what you want to do with that optional value, particularly if it doesn't exist, in a more functional way. The simplest thing is there's the addition of is empty. Like I just said for the not case, humans are kind of not that great at parsing a negative. So it's not easy for us to see a not. And so where we say if not is present, what do I do? So what does that really mean? In Java 11, I can flip that and I can say if is empty. So by using the positive case, if you like, it's clearer. If it's empty, this is the thing you do. So again, it's a stylistic thing. I might take the choice to do that. What else can I do? So we have a optional value or throw. So I can have optional or else throw, and it takes a Lambda expression to create the specific exception that I want to throw. So instead of just throwing a null pointer or something, I can throw a very specific exception of I don't know, no users found exception or whatever. One of my favorites is if present or else, because what I found myself doing, like I said, I was working on this code base with a lot of nulls. When I started trying to convert it to using optional, what it often did is you would have, obviously, if the null, if it does exist, do this thing, that's fine. Else, do something else. So when you have an if else, you still had to put it inside an if else, and you couldn't do anything really functional with Lambda expressions in really, fluid style. Now with Java 11, you can say if present or else. You say if present, you're going to do this thing. If it's not, do something else. So you can actually just use two Lambda expressions instead of having to wrap this inside an if else. You can use or. Or is a way of using another optional. So get customer returns an optional. So you say this optional or another optional. The other optional methods were all around using the actual value or something of the type of the actual value. So this allows you to start playing with the optional wrapper instead. And there's a dot stream method which makes optional a little bit easier to use inside stream operations as well. It just makes it a little bit less of a need to unwrap things and do any if else's type things. Let's fold those up. So that's optional. I think optional is much easier to work with in Java 11 than it was in Java 8. It just makes it a bit more of a viable choice. There's a built-in HTTP client in Java 11. I haven't played with it yet, but I really do want to start using it. I feel like it could be helpful it's definitely helpful for testing for sure. It could also be helpful for some of the microservices stuff if people are doing that. I think not having to use a third party for some of these things might make life a lot easier. Certainly this was suggested to me by people who were saying that's what they were looking forward to using when they moved to Java 11. Multi-release jar files. This is useful for library developers. So if you're not developing a library that's used by other developers, you might not see the value in this. A multi-release jar file is where I'm a library developer. I create my library, I package it in a jar file, and that multi-release jar file says that if you are using Java 11, you can use my jar with Java 11 features. If you're using Java 8, then you use my jar with the Java 8 features. Now, it's not exposed at the API level. It's more under the covers. But it's very helpful for library developers because they can actually start migrating their libraries to newer versions of Java. I can tell you from experience that in the past, without a mechanism like this, as a library developer, you're kind of tethered to the lowest common denominator of your users. So if your users are still using Java 6, you can't migrate your library beyond that. With multi-release jar files, you can start using some of the newer versions of Java and hiding it from the end user. And your end user only has to download the one jar file. You don't have to say, this is the Java 8 one, this is the Java 11 one, this is the Java 14 one. So this is a really helpful mechanism for helping the whole community move forward towards the latest versions of Java. There's a blog file here. I wrote this blog file back in 2017. I was playing around with how to create a multi-release jar file in IntelliJ IDEA. It's not, I'm sure there's better tutorials now, but it gives a good overview of how the mechanism works and how you can get it to work for you if you're interested. Jigsaw. So Jigsaw was the big ticket feature for Java 9. We're supposed to call it the Java module system. And the Java module system might not seem super exciting to a Java developer, especially if you're already working on either a monolith or a system which has already been packaged into multiple modules in some other way, then you might not really care that much about the Java module system. But in actual fact, modularizing the JDK itself, splitting it into smaller modules, has made it easier, well, has made things like the 6-monthly release cadence more possible, I think, and has made it easier for the language developers to provide us with a bunch of other things we couldn't have had before. For example, JLink. JLink is a tool which allows me as an application developer to bundle up just the bits of Java that I care about, that I use, like java.lang. What else could I use? Java.lang and I can't even think of the other ones in the JDK, and the logger, and a couple of other modules, and not any of the other modules that I don't use. So I'm not going to bundle up Swing. I don't use that. I don't use AWT. I don't use JavaFX. I just use these modules that I use, bundle all that up into a small deployable and deploy that maybe to the cloud. And of course, having small deployables is helpful. It's smaller and shorter to upload. It's going to potentially cost less in terms of space, in terms of passing stuff over the network, and so on and so forth. So JLink is a really interesting tool which is available now in Java 11. Right, let's pause there and take some questions around the Java 11 features available.
Yes, so actually we do have a question or two questions already about optional. So Yuri asks, is there a difference between optional.or and optional.or else?
That is a good question. Let's have a look. So we have an optional customer. Let's see. I want to move that over here. So I have optional.or, which, okay, so you say it's either this optional or go and get this other optional. And what was the other one? Optional.or else. Current customer. Or else or else. Yes,
Or else,
yes, exactly. And that's exactly the right question to ask. So, or else, let me see if I've got the right thing. I could say new customer maybe with a name and a what was that surname? Who knows? Something. So, or else, with optional.or else, you have to give it, in my case, what I have is I have an optional which wraps a customer object. And so, or else, I say it's either this customer that's inside this wrapper or this alternative customer object. Whereas or is different, so or else. Or is different. Or is the optional wrapper, current customer, or optional wrapper of another customer. So the short version is or else returns a customer and or an optional. Now that might not seem, you might sort of think, well, why? Maybe I would unwrap that anyway, so it doesn't really make a lot of difference. When I was trying to migrate an existing application, this one that had a lot of nulls, I was trying to migrate it to use optional. I think it's a bit different. If you build your application from the ground up, knowing that you've got optional, I think you can do all the right things with it and you don't need a lot of these methods. But when you're trying to do a migration and you've got existing code which says, okay, I've got this value, it might be null, it might not. So then I need to do this. But if it isn't null, then I need to do that. And then otherwise I need to go off on here, get another thing which may or may not be null. So it might have to go to the database and get like a, I don't know, customer number 2. And then I need to chain again, basically these complicated if-else null checks. So for example, and so I think that would be useful for there. This is when my current customer, I'm going to get a customer. It might not exist. So then I'm going to get another customer, but then that might not exist. So then I'm going to say, or else default customer. Okay, so it's all about chaining operations in this nice functional way.
Yeah, makes sense. Fair enough. And I think you showed a very nice approach implicitly. Like what happens if we have these questions? It makes a lot of sense to just look into your IDE and especially the Java doc available, and it will tell you if you read through it. I think that's always very helpful to just understand what it is for. Sometimes even with examples. So. Yes.
I do it all the time. I do it all the time, especially with optional, because like you say, I know that optional, sometimes it's got a wrapper, sometimes it hasn't. So what I'm doing is I'm holding down Command and hovering over it to see what am I going to get? What does this do?
Same here. Even for map, like map dot all the new methods, I cannot remember which one is which, and I have to read every time. But that's fine. So another question: in case of endless streams, what we need to do to get an analog of take while behavior in Java 8?
I managed that, and I did a massive hack. It was hard. The short version is without take while. It's really hard. There is a massive hack that you can do because, of course, all of the variables you use inside a stream call, they should all be effectively final. So you shouldn't be able to manipulate them, but you can use a field inside a stream operation, and you can change that field value. So for me to hack the take while operation, I had a field called something like what was it? Like it was called finished or something. So the finished was false, and then I could set that. It's not a Boolean. It has to be an atomic Boolean or something like that. It has to be something which is thread safe. But I would set that value to be true and have some check. Where was that? Somewhere in the stream operation to say, like, it was a filter or something like that. I can't remember. It was a huge hack, and it was a bit fragile. So without take while, it's very difficult to manage infinite streams inside Java 8. I actually ended up with a lot of my Java 8 infinite streams. Granted, this is demo code, not real production code. I just basically Control C and kill the thing when I'm done with it. It's really tricky to fake the take while functionality in a good and sensible way.
Fair enough. That makes sense. Another question related to multi-release jar files. Does multi-release jar files feature requires to make changes in the source code? For instance, mark some APIs version specific?
No, well, see, that's the thing. The deal about multi-release jar files is that you shouldn't use it to offer different APIs. And that's one of the limitations. So if multi-release jar files came in Java 9, so you can target versions of Java from Java 9, you can target individual versions of Java 9, 10, 11, 12, or pre-9. So you can't say, this is the Java 6 API, which doesn't have stream support, and this is the Java 8 API, which does have stream support. You can't use multi-release jar files to dictate the API that your developers see. What you can use it for, though, for example, is Java 11 has the HTTP client built in. So if I'm developing a library and I give you my multi-release jar file, if you're using Java 11, I can use the HTTP client built into Java 11. However, if you are not using Java 11, I will use Jetty or something similar. So that's the level we're talking about. We're talking about sort of under the covers. What can I do? Can I use things like under the covers? Can I use unsafe in a particular way versus should I be using some of the new versions, new functionality that came in inside Java, the language, to replace some of the features of unsafe, for example. So it's more about as a library developer, which features in the JDK can I use internally? What version of Java can I rely upon to be running? So it's not really about me as a library developer being able to offer you, this is the Java 8 API versus this is the Java 11 API.
That makes sense. Yeah. All right. Then we have a few more general questions about migrations, but I would suggest we continue for now with the more detailed features.
Okay. I'm surprisingly running out of time. I thought that I don't know why I'm surprised by this. I've always got so much to talk about. So we've got 20 minutes left. Right. Language features in Java 14. So again, like we did with the 11, the language features available in Java 14 batches up all the changes which came in 12, 13, and 14. One of the big things which is available in Java 14 is switch expressions. It's not big, it's a small thing, but it's nice. So switch expressions came in as a preview feature. Oh, we should talk a little bit about preview features, actually. With the 6 monthly release cadence, with the way that the language is being evolved right now, the JDK now has this idea of preview features. They're not turned on by default. You have to turn them on with a build flag. Let's see if I can find the build flag in my POM. So I have to turn them on. There we go. In my Maven plugin, Maven Surefire plugin, I have to turn on enable preview. And here in the Maven compiler plugin, I have to turn on enable preview. So preview features, don't use the preview features in production. This is why you have to turn it on. It's a good place. It's a good idea to use them maybe in test, but certainly to play with them. The idea of a preview feature is to give a mostly completed, probably completed feature out to real developers for us to experiment with, to use in real code bases, for us to be able to feed back to the language developers. Does something like the new switch expression, does this make sense to us? Does this does the syntax look right? Does it seem sensible? Is it going to be difficult to migrate to? And then this way, the language developers can offer various versions of the preview feature. So every 6 months, that preview feature has a potential to change a little bit, which is why I say don't use it into production. It could change every 6 months. And then at some point, it has had enough feedback, there's enough stability, enough happiness that it gets marked as a standard feature. It's no longer a preview feature. Now, why is this relevant? Switch expressions is a standard feature in Java 14. It was a preview feature in Java 12, which is why this says Java 12, an IntelliJ idea. It was a preview feature in Java 12. In Java 13, they made some small changes to the preview feature according to feedback. And then by Java 14, they didn't need to make any changes, so they made it into a standard feature. So now it is a proper, fully fledged feature of the language. So what's a switch expression? Let's look for switch expressions. Everyone should know what the standard switch statement looks like. Probably we don't use these because this looks like something straight from the 1990s. And oh my goodness, it just looks so ugly. Plus also it's generally a breakdown in polymorphism and good object-oriented design. However, there are times when we have to use a switch expression. Often when we're taking input from the edges of our system, so maybe from an external system or from a user or from a database, sometimes we have to take these raw values and turn them into something more object-oriented, domain-driven inside our application. And the only way to really do that is with a switch statement. So for example, here we get an int, which is a port, and I want to turn that into an enumeration value of this port so I can do something useful with it. And this is kind of clumsy. We hate the fact that it's got labels. We hate the fact that it's got break and colons and stuff. It's just it just looks extremely old school. So, and the other thing that we hate about it is if we want to assign a value from these, we have to have a variable, which is literally a variable that gets mutated and then gets mutated somewhere in here, and then I can return that value. So it's not great. So I can't call that final, can I? Oh, why can't I call that final? Ooh, I don't know the answer to that question. Anyway, so you end up mutating values. I'm really confused by that. I can turn this into a switch expression. Now I'm using Java 14. Now switch expression is a lot shorter. So it's much prettier. And we use nice lambda arrows, and we don't have any colons or any labels or anything. So, and I can still have a default value. And in actual fact, yeah, that's not surprising. And I can inline this. So I just straight up return that value. I don't have to do anything. So, it's just a much more compact way of doing stuff. And because it's more compact, because everything fits on a smaller number of lines, it's easier to parse straight away, like what's going on. And I can have like multiple values. I had this in the switch statement anyway, but I can have multiple values there as well. And so it's a much prettier way of doing switch statements. it doesn't have to just be as simple as returning one value either, though. So I could turn this into a code block, and then I can say like do something complicated here. And then I use the word yield to return the value from the switch expression. This is the thing that actually changed from Java 12 to Java 13. This used to be called break, and now it's called yield. So it's that kind of feedback which happens between those different preview features. So I like switch expressions. I think they're really cute. IntelliJ IDEA provides some really nice support for it as well, so we can really easily migrate to them, and we can figure out if I get rid of this, IntelliJ can tell me create missing branches for all the stuff that's missing, and so on and so forth. I mean, that was there, I think, for switch statements anyway, but it's some nice features in IntelliJ. So switch expressions is nice. Text blocks. This is a really good example of what preview features are good at. Text blocks was originally called multi-line strings, I think, which was a different thing, and that was iterated over, and people said it didn't really work, and they couldn't figure out, it just didn't add the value. The point about a text block or a multi-line string was to be able to support big blocks of strings inside Java code and have it not be completely ugly. So this has been through a whole bunch of different iterations. We're currently on the preview. In Java 14, this is still a preview feature. In Java 15, this will be a standard feature. So, and it won't change. So we can actually use the one that's in Java 14. I'm not sure if you should. You can use the one that's in Java 14 as if it's not going to change, as if it's a standard feature. Let me show you text blocks, because I like text blocks as well. None of these are groundbreaking features, but they're all nice. They all make it a lot easier for us to write readable code. So here are some examples of, like, I've written code like this in the past for sure, where you have HTML embedded in your code, or maybe something from a different language, definitely SQL. The other example is something like JSON or XML. It's quite common to see that embedded in your Java code. Now I can actually turn this into, where is it? So I can, I've lost it. Fine, let's do it on here. Replace it with a text block. A text block starts with 3 quotes, ends with 3 quotes, and you don't need any more quotes in between, and you don't need to escape anything either. So I no longer have to escape any of these. We just know that everything inside these 3 quotes is a string, basically. I don't have to do anything else. It's also, the indentation is also significant. So this line here dictates the start of this particular block. So if I put that in by 1, then this white space counts. This white space is part of the string. And we can see that in IntelliJ, we see that by this line here. This line shows where the start of the significant white space is for this block. So that's kind of nice. IntelliJ as well, in case you didn't know, I love this feature. You can inject a language. So here I could actually inject JavaScript, and I can actually treat this as if it's JavaScript. So I can actually get code completion here for JavaScript inside my string. This applies to standard strings as well. This has been here for ages. It's a feature that a lot of people don't realize, and it's super helpful, particularly for around offering things like, I think I've used it for JSON so that IntelliJ goes, you haven't closed this JSON string off properly, or this is badly formed. So yeah, so text blocks, you can use it for all of these different things here. Your XML, HTML gets a bit more easy to parse. Surprisingly, my SQL actually looks okay, but I think I chose a poor example for my SQL anyway. So yeah, so you can use text blocks starting with 3 quotes to enclose a big block of string. All of these blog posts are, not surprisingly, from the IntelliJ IDEA blog. That's because me and my colleague Mala, we usually write some sort of update. Usually Mala writes an update for what happened in Java in the last release, and what are the cool features that you might want to see. So this is our blog post where we talked about text blocks. Records is my new favorite feature. We are running out of time. I'm really amazed. Records are my new favorite feature. Records are fairly easy, so let's show you what a record is. You already saw a record in an early example, but you might not realize what it was. So I can create a new Java class. I'm going to call it user. Is that a good idea? I'm going to call it person. Can't remember what I've already got. I'm going to create it as a record. My record, yes, sure, add it to Git. My record is going to have, my person is going to have a string name, an int ID, and I don't know, a bunch of other stuff. So this is my record. I don't have to do anything else. This class now automatically has a constructor that matches that signature. It has getters for the name and the ID. It has hashcode string, hashcode toString, and equals, and they're all there. I don't have to do any of that stuff, and I can just use that straight away. If I show you a record test, let me show you this record. Oops, yeah, what happened? Let's get rid of this for now. So here's a record with, again, an ID and a name. And in my test, I can say, let me run that so you can see the system at println. You can see the toString. Love running stuff in Java in the middle of a demo. It gives me a nice break between talking. I should have compiled this beforehand. It's thinking about it. Anyway, while it's doing that, let me show what the record looks like to work with. So I have a Trisha. My getters, note that my getters don't start with the word get. I actually just have ID and I have name. And I have a name there. So those are my getters. I wonder what happens if I drill into it. Oh, and then it takes me to the record component inside IntelliJ IDEA. It's still building. What did I do to it? So there we go. And I get a reasonable toString there on the output. And my equals, you can see that if I create two records, Mala and Trisha, then they're not equal when I compare them. So records are a really nice feature. And in this demo code, I've started replacing all of my simple objects, which were just data transfers or very simple domain objects. I've just converted them all into records because it's just a lot easier to work with and I don't have to think about what it looks like. I am kind of running out of time. I do want to show you one more thing with records, which is that if I generate a constructor, I can create a canonical constructor, which is a sort of standard constructor as it was there. Why would I want to do that? I don't need that. In fact, IntelliJ says I can get rid of that if I want to, because that's already automatically done for me. But I might want to do something like, let's paste this back in here. I might want to do something like, I want to validate my fields first. And then set my fields. So I can override the constructors, I can override the getters if I want to, and I get the functionality I want. The other thing I want to show you is that that was overriding a canonical constructor, so it's the sort of constructor that we're used to seeing, and you can actually use the compact form because in this constructor, I am using the two fields that make up the record, so I don't need to declare those. It's just I can just magically get those. Shouldn't use the word magic, but you know what I mean. Right. Oh my goodness, 8 minutes left. Pattern matching for instance of also came in, is also a preview feature of Java 14. I will show you a really quick version of this. If you're doing something like a cast, you do person instance of, and then you do a cast, you don't need to do that anymore. In Java 14, you can just basically say person instance of employee, and then you can use the employee as if it was an employee. Again, reduction in boilerplate makes it a bit easier to parse. This is the beginning of a bigger trend of pattern matching in Java. We will see more pattern matching coming in over time. Right, let's talk a little bit about beyond Java 14. So Java 11 has some nice features. Java 14 has some really nice features, but a lot of them are preview features. Let's talk quickly about Java 15, especially because we are in July. 15 will be out in 2 months. So almost as soon as, if anyone is watching this in just 2 months' time, this is already out of date because Java 15 has a bunch of features. Java 15 will have text blocks as a standard feature, so will no longer be preview. The pattern matching for instance of, which I just showed you, will be going through its second preview. At the moment, that second preview is not due to change. It will be exactly the same as it was before. It's just time to get a bit more feedback. Records will have a second preview. There'll be some changes for records, which I haven't quite tracked down. I think that might be something around the way it works in the underlying, I don't know. There will be a second preview of records. There'll be a preview of sealed types, which says I have a class, but only certain things are allowed to inherit from that class, are allowed to override that class. Hidden classes will be available as well. ZGC is a new garbage collector which will be available for production in Java 15. And if you want to know all the things which are available in 15, go to OpenJDK 15. 15 EA Early Access is available now, so you can actually start using 15 now if you want to. And in the future, we have all of these things that we've seen, all of these small features. A lot of them fall under big umbrella projects. So Project Amber is a big umbrella project, which is all about reducing boilerplate, aiding readability. So a lot of the features that we saw here, things like var and stuff like that, all comes under Project Amber. And Project Amber has a bunch of other features which are coming in future, which will be dripped in over these 6 monthly releases. Valhalla is about, oh my goodness, I always get this wrong. So Valhalla is about inline types, or it's all about efficiency of the way that objects are laid out, or not even needing objects. You want to be able to have, you want to be able to use things as if they're co-located in memory. I sound like I don't know what I'm talking about, but Valhalla is basically about performance, and it's really interesting and will come at some point. Loom is about really lightweight threads. So this is going to be a really interesting model for concurrency going forwards. This is in progress as well. We've had a whole bunch of garbage collector improvements, which I'll talk about a little bit later on. We've got 5 minutes left. There will continue to be more garbage collection improvements too. There's a proposed new project Laden, which is around the startup time of the JVM. So that's also ongoing. So it's a really exciting time for Java at the moment, and things are just accelerating as far as I can see. Now, fine, I just showed you there's some complicated politics around support, licensing, and updates. There's a whole bunch of language level features, nothing as mind-blowing as lambdas and streams perhaps, but lots of things to make the code more readable. But the business doesn't care about that. How do you sell it to your organization to say we need to be on Java 11 or Java 14? Let's talk a little bit about things that perhaps the business or your leadership does care about. Performance. The decision makers and the users probably really do care about the performance of your application. Generally speaking, when you migrate an existing application from an older version of Java to a newer version of Java, you will generally see an performance improvement without really doing anything else. This is due to things like improvements in the way the runtime optimizations work, improvements in the way that memory is used. There's usually underlying stuff for using particular CPU instructions if they exist. So you will generally get better performance without having to do anything else. Related to that, better use of memory. So compact strings were added. I can't remember which version. It should be available in Java 11. So you should see, moving off Java 8, you should see a better use of memory. This might be important if you're running in the cloud and, obviously you have costs for running your application. Related to that, a lot of garbage collection improvements in Java 11. So G1 was made the default garbage collector in Java 9. So when you move to Java 11, if you haven't done anything with your garbage collector, you will now be using G1 as the default. And then a bunch of additions and changes for G1, and 2 new experimental garbage collectors, which you might want to try out to see if they give you better performance for your application. In Java 14, another new experimental garbage collector, Shenandoah, more updates to G1, more improvements to ZGC, which was one of the experimental ones in Java 11, a bunch of stuff for ZGC. A bunch of deprecations there. So lots of garbage collector changes in Java 11 and Java 14. I'd be really interested in running applications using different garbage collectors to see if you get a different performance profile there. Related to those things, with improved performance, with smaller memory footprint, with more efficient garbage collectors, you might see a reduction in cost, certainly in terms of the running hardware of your application or whatever. What I think is an interesting area of cost as well, though, is in terms of recruitment and retention of developers. Java 8 is fine. We like Java 8. It's still not, certainly by Java standards, it's certainly not old, and it's kind of fine, but there's going to come a point in time where it's going to be difficult to recruit and retain Java developers if your application continues to work on Java 8 with an old application server and an old technology stack. There's going to come a time where people are like, well, there are other 31% of applications are running Java 11 now, so I'm going to go and work for an organization that is running at least Java 11 and is maybe experimenting with later versions of Java because I need to keep my skills up to date as a developer. So there's a sort of opportunity cost there around retention and attraction of your developers. Tips for migration. I have no time for tips for migration, and I bet you loads of people are interested in this topic. You could try running on the updated JDK. I don't mean compiling against updated JDK. I mean putting JDK 11 in in continuous integration and running your application on that JDK to see if it just works. I tried this with a few apps. It did just work. And it's kind of designed, this is Java. Java has backwards compatibility. So even if you've heard horror stories of like how everything is broken, I still recommend trying it. It probably will just work. There's a lot of cases where everything is kind of fine. But even before you start using a new version of Java, address compiler warnings, address deprecation warnings, any warnings which are coming up in your code, you will see them. You see them in Java 8. It says things like, this functionality is going away. Stop using it. Excuse me. Deprecation warnings are there for a reason, and post Java 9, certainly, deprecation is something to take seriously. There are a bunch of things which have been removed from the language in Java 11. So if you see deprecation warnings, make those replacements now before you make any improvements or updates to your JDK. Update your dependencies and maybe add new ones. So you do need to update your dependencies. You should do this anyway for security reasons. You do need to update dependencies. You might need to add some new ones. Some stuff went away in JDK 11, as in it's now external. So Jaxby, for example, you need to add an external dependency on Jaxby if you're using it because it's no longer part of the JDK. You do need to update your build tool. You need to update Maven and Gradle. They won't work. The old versions won't work with Java 14. And then you can compile against the updated JDK and you can start using the shiny new features. I wrote a whole article specifically around migration. It says upgrading Java 8 to 12, but it applies to 14 as well. That goes through a lot of these steps and how to do it. Let's just go straight to here. Ta-da! I finished on time.
All right, that was just right on time. That's great.
Yeah, it's
So,
just
yes,
a second. So we're kind of out of time for the question session, but I guess you will follow the link in Zoom webinar and answer them there. So thank you, Trisha. Thank you, Sebastian, for support. It was a really amazing and nice experience. Now I know how to use vars, and now I know that IntelliJ quite smart and won't suggest me to place them in the wrong way. Thank you very much. See you there.
Thanks a lot.
you.